Good morning, everybody. Here is our second lesson on the renewable energy, and this lecture is called geothermal energy. A bit of the history. Just a question: what is the geothermal energy? It is simply power derived from Earth's internal heat. Geothermal energy has been used by people for thousands of years in some countries for cooking and heating. The first geothermally generated electricity was produced in Italy back in 1904. There are three main ways to use the geothermal energy. The first one is to produce electricity when underground water, hot water and steam can be tapped directly to generate electricity. Also, geothermal heat can be used for cooling and heating houses because 3 meters of Earth have approximately constant temperature. So in the winter, the hot water can be used for heating houses, while extracting heat from the building and transferring it back to the relatively cooler ground can be used in the summer to cool houses. And also geothermal water from deeper in the earth can be used directly for heating homes and offices, or for growing plants in greenhouses, which is used widely in Iceland. Here is a simple slide about electricity production. To produce geothermal generated electricity, wells are drilled into underground reservoirs to tap steam and very hot water that drive turbines linked to electricity generators. After the generator, cold water is pumped back underground. The wells are usually very deep. They are a mile or even deeper than a mile. There are 3 main types of geothermal energy plants. Dry steam, which takes steam out of fractures in the ground and uses it directly to drive a turbine. Flash plants pull deep and high-pressure hot water into cooler, low-pressure water. The steam that results from this process is used to drive the turbine. And the last one is a binary plant, which takes hot water and that hot water is passed by a secondary fluid with a much lower boiling point than water. This causes the secondary fluid to turn into vapor, which then drives the turbine. Most geothermal power plants in the future will be binary plants because this technology is much more efficient. There are certain advantages of geothermal energy over other types of energy. Geothermal energy can be extracted without burning any fossil fuel, which is great. Geothermal fields produce only about 1/6 of the CO2 than a relatively clean natural gas fuel power plants. Binary plants release essentially no emissions at all. And unlike solar and wind energy, geothermal energy is stable, and it can be used 365 days a year. And also, the geothermal energy is relatively inexpensive. Savings from direct use can be as much as 80% over fossil fuels. But anyway, there are certain disadvantages of this technology. Producing geothermal energy releases hydrogen sulfide into the atmosphere, a gas which smells like rotten eggs. Disposal of some geothermal fluids may contain some low levels of toxic materials. And also geothermal sites are capable of providing heat for many decades, but they may eventually cool down. Geothermal energy is used in approximately 20 countries all over the world. The United States is the world's largest producer, And the largest geothermal development in the world is the geysers north of San Francisco in California. In Iceland, many of the buildings and even swimming pools are heated with geothermal energy. And Iceland has at least 25 active volcanoes and many hot springs and geysers. We are going to talk about geothermal energy in Iceland in detail. So why Iceland is so popular to use geothermal energy? There are two reasons. Actually, just one big one. Iceland is one of the most dynamic volcanic regions in the world, and because of its geographical location, because it's located over a rift of continental plates, Iceland has very unique and special conditions needed to generate geothermal energy. All geothermal energy produced in Iceland is governed by the National Power Company of Iceland, which currently operates 18 power stations all over Iceland in 5 areas of operation. It has 15 hydroelectric power stations, 3 geothermal power stations, and 2 windmills. The National Power Company of Iceland is one of the largest producers of renewable energy in Europe. So I will briefly describe power stations, the biggest geothermal power stations in Iceland. And we can start with the Hellisheiði power station. This is the biggest one in the country and the 3rd largest power station in the world. It's located in Hengil, southwest of Iceland. The plant has a capacity of 303 megawatts of electricity and 133 megawatts of hot water, which is mostly used for Reykjanes district heating. The station has been commissioned in 2006. It's a flash steam station with 50 wells, and the wells go as deep as 2,200 meters. The second biggest station is Nesjavellir geothermal power station. It's located quite high, 177 meters above sea level in the southwestern part of the country. The station produces approximately 120 megawatts of electrical power, and it serves the space heating and hot water needs for Reykjanes. It has been commissioned in 1990s. It's also a flash steam power station with 21 wells, and the wells are as deep as 2,000 meters. Reykjanes power station is located in Reykjanes in the southwest tip of Iceland. It has been commissioned in 2006. It's a dry steam power station with 12 wells, and the wells are quite deep. They are 2,700 meters deep. This power plant generates 100 megawatts from 2 turbines using steam and brine from a reservoir at 290 degrees of Celsius, which is extracted from Celsius, as I said. This is the first time that geothermal steam of such high temperature has been used for electric power generation. The power plant is open to the public and houses the power plant Earth exhibition. Svartsengi power station. This power station presently delivers 75 megawatts of electrical energy and 150 megawatts in thermal energy. The power station consists of 6 units. The first unit, the oldest one, it has two back pressure turbines, which deliver around 50 megawatts of energy for its own power needs. And today, that energy unit is mostly out of action, and only 2 circuits are in use. So the produced capacity is just 25 megawatts of thermal energy. The second unit was built in 1980s, and it has 3 thermal energy exchange systems and produces around 75 megawatts of energy. The third unit has 6 megawatt counter pressure steam turbines and is used for producing mostly electricity. The fourth unit, which was built in 1989, has 7 1.2 megawatts turbines. The fifth unit was built in 1999 to practically replace the first one, and presently it produces 30 megawatts. So it has 30 megawatts turbines and produces 75 megawatts of thermal energy. And the last unit, number 6, is a condenser plant with unique high pressure steam turbines and a total capacity of 30 megawatts. It produces only electricity, which depends on the using of the district heating and electrical use. And Krafla power station, as it's spelled in Icelandic. This power plant consists of 2 30 megawatts units with double pressure inlet and dual flow turbines with 5 steps on each side. It takes its energy from 17 high pressure production wells with 110 kilograms per second of 7.7 bar and 5 low pressure production wells with 36 kilograms per second of 22 bar. The other 7 wells are not in use, and 5 wells do not even exist anymore. The turbines consume 2.5 and 17.8 kilograms per second of high and low pressure steam each. If the inlet pressure and the mass flow were raised, the output of both turbines could be increased to 35 megawatts. One of the additional wells, which was drilled in the Krafla geothermal reservoir in 1999, is nowadays known for being the world's hottest geothermal well, since its borehole reaches magma and its lowest point has a temperature of 430 degrees. That's all about Iceland, and just short conclusions. So Iceland is a geothermal energy pioneer. Iceland has a unique geology thanks to volcanism along the rift, and it provides which provides sustainable advantage heat from the ground. With this geothermal heat and innovative engineering, Iceland can provide hot water and electricity in their homes, warm the snowy streets, produce fresh vegetables, and much more. Around 25% of Iceland's electricity comes from geothermal sources, and it's amazing that almost 100% of Iceland's space heating and water heating is obtained from geothermal sources. Thank you for your attention, and I'm ready for your questions. Thank you.